name is Ilya Muzyukin. I'm from the Institute of Electrophysics of the Ural branch of the Russian Academy of Science. And my report is called The Measurements of Vacuum Arc Behavior at a Threshold Current. The report is devoted to some features of the discharge parameters of low current vacuum arc at the threshold currents. Sorry. Motivation. The mechanism governing the process of cathode spot purchasing remains unclear. In order to understand what affects the process of the appearance of the cathode spot when the threshold current is exceeded, as well as the division of the cathode spot when the current value is exceeded two values of threshold currents, is necessary to carry out detailed experiment in the region of low currents. In other words, where the cathode spot cannot be much smaller or much larger than it really is there a correlation between vacuum and threshold current and the erosion in the cathode spot. The experimental setup. The cathode was a brush-like structure. In this brush was the copper pin, tungsten pin and graphite pin. The discharge was ignited at one of the cathodes using an ignition electrode. This is ignition electrode. The igniting anode was attached via the resistor of 4 kilo ohms. The limiting resistor sets the initial discharge to 4 amperes. Ion detector was rigidly fixed to the initiated electrode. This is the connection. The ion detector had a coaxial conical structure. Connection. This is a trigger electrode. It's a simple arcanoid. At the top of the cone, there was an aperture with a diameter about 300 of micrometers. Behind this aperture, an ion collector with a diameter about 100 micrometers was placed. The distance between the collector and cathode surface was about 100 micrometers. The main idea of ion current measurements is the use of small-sized, very close-placed ion detector as the delay time of ion current from the cathode to the ion detector was less than previously estimated lifetime of the cathode spot. And experimental results. This slide you can see experimental results by waveforms of discharge current, ion current, and plasma luminescence. What can we say about these results? On the threshold current level, the discharge current have significant instabilities, but ion current have very significant instabilities. So one can say that current of ions consists of very strong bursts or very strong peaks. Such peaks can be connected to the cathode spot operation, single cathode spot operation. And overall plasma luminescence have no any peculiarities. And in the case of tungsten cathode, one can't notice significant instabilities in the current, arc current, but in the ion current, the instabilities remains, and they makes about 20, maybe 30% of overall current, and the same as in previous case. At the end of the current chopping, there is very intense ion burst. So we can conclude that maybe we have some evidence of short, maybe explosions on the cathode, as named by academic methods as ectons. But at the graphite cathode, there is no such evidences, there is no such behavior of ion current and the current of discharge. There is no significant bursts or peaks on the ion currents and on the arc current. Besides, there is no significant threshold current. We have at this waveform about 100 milliamperes of chopping, and in the previous cases we have chopping current or threshold current about 1.5 ampere of threshold current. So at the tungsten and copper cathodes there is very big threshold current in comparison with graphite one. And there is a Fourier spectrum of parameters of arc, vacuum arc, the current, ions, lights. In the ion Fourier spectrum, there is some significant local peaks in the region of several nanoseconds and tens of megahertz. The question is how the presence of ion current bursts can be quantitatively estimated. We have used the modification of wavelet representation of the ion waveforms. The usual wavelet integral was substituted by the sum of local maxima of wavelet spectrum. There is so-called skeleton of wavelet spectrum and the local maxima. We substitute all spectrum by this maximum. So we can restore the initial waveform by the set of pulses of wavelet analysis. The wavelet was made with use of Mexican head wavelet. And we can restore the positioning and duration of pulses. So we can quantitatively analyze the iron bars from the cathode spot. And on this slide, one can see the local peak wavelength spectra. So, at this spectra, one can see the presence of significant local peaks with several and tens of nanoseconds, with copper cathodes and tungsten cathodes, but on the graphite cathodes there is no local peaks on the area of several, in the region of several nanoseconds, several tens nanoseconds. And the noise spectrum is very smooth. By the way, our investigation of vacuum arc on the tungsten cathode coated by the fuse nano coating shows that if the vacuum arc works on the clean surface, then we can see the normal level of threshold current. And when the vacuum arc operates on the coated with fuse surface, there is a very small threshold current, the current of chopping of vacuum arc discharge. Even in some cases, we could not see any chopping of current discharge on vacuum arc discharge. Or this chopping current, on threshold current, was on the level of noise. There is no steep or significant noticeable drop. And possible explanation. Possible explanation is when the vacuum arc, the cathode spot of vacuum arc, needs to evaporate and erode big amount of matter, big amount of metal. In this case, we have the following parameters. The volume is big, and the time for evaporate is big, and so the threshold current need to evaporate and ionizate this volume is too big. When the cathode material need no much volume to evaporate, then the time of evaporation, the time of cathode spot life, and threshold current could be very smaller. And in the case of nanostructured surface, there is the nano-sized volumes of material, of cathode material. So we can get on the normal metals the noticeable threshold currents, and on the graphite cathode, some special cathodes, we have very small threshold currents, and on the nano-coated cathodes, the threshold currents can be practically absent. The conclusions. Measurements of the parameters of the arc discharge at a threshold current show that plasma in the cell of the cathode spot is generated in portions on copper and tungsten cathodes. These portions are noticeable only when approaching the threshold current. The threshold current is a necessary current for the explosion of a cathode microvolumes. The larger exploded volume, the higher the threshold current and the more noticeable the portion nature of plasma generation. That's all. Thank you for your attention.